This is 2014 question 1. So based on this looks like an accumulation problem, I would say. It's a little bit of everything, so you can't really put it on one FRQ here. But here we go. So they give us a function here. Notice that A of t is the amount of grass clippings, so it's not the rate, okay? So just keep that in mind. And then they define everything, okay? So part A, find the average rate of change of A of t from 0 to 30. So basically, if you think about it from 0 all the way to 30, we need 2 points here. The y value would just be A of 0 and A of 30, okay? So basically, y's go on top, A of 30 minus A of 0 all over 30 minus 0. So the way you would do that on a calculator is you would definitely program A of t as y1. And when you go to your home screen, you would just do y1 parentheses 30 minus y1 parentheses 0 all over 30 minus 0. Okay? Make sure that you're grouping the numerator and the denominator. And you should get negative 0.197 or 196, okay? So notice how they ask you for the units of measure here, okay? Very easy to do. So remember, A of 30 and A of 0 is measured how? So if you take a look, A of t is measured in pounds. So at the top, you have pounds, or LBS. And at the bottom, 30 minus 0 is a measurement of time. And time is measured in days here. So that would just be pounds per day. Okay, here we go, part B. Find the value of A prime of 15. So basically, you have y1 already on your calculator. So you just have to find the derivative of y1 at 15. So that's pretty much math 8. So that's d over dx of y1 evaluated at x equals 15. And you should get that. That's a quick plug and chug that you should get. Okay? Using correct units, interpret the meaning of. Okay, so take a look. Your derivative, I'll write it over here. Your derivative came out negative. So implications, A is decreasing. Okay, so the only question here is what the heck is A? Remember, so A, if you go back, A represents the amount of grass clippings. And what do we know about the amount of grass clippings? It is decreasing. Okay, so here we go. The amount of grass clippings is decreasing at a rate of, and then you put 0.164. Notice how we didn't put the negative, okay? So the decreasing takes care of that negative part. And that is decreasing at a rate of, so remember, when it's a rate, it has to be something over something. Okay, so in this case, it's pounds per day at that particular moment. T equals 15 days. All right. Here's part C. Find the time t where the amount of grass clippings in the bin is equal to the average amount of clippings in the bin over the interval. So let's break this sentence down a little bit. The amount of grass clippings in the bin. That is A of t. Okay, is equal to the average amount of clippings over the interval from 0 to 30. Average value, so that's pretty much 1 over 30 integral from 0 to 30 of A of t dt. Basically, you're setting up this equation right here where A of t is equal to 1 over 30 of the integral of A of t from 0 to 30. So if you do that, right now in your calculator, you should have this as y1. You can figure out what this is just by going to your home screen and just doing math 9. That would be from 0 to 30 of y1. Okay? And you should get a value. Okay? Whatever that value is. Then what you would do is you would type this into your y2. Or you could just type in this whole thing as your y2 to begin with. It's up to you. But basically, you're going to graph y1 and y2, and you're going to see where it intersects. Okay? Two things you could do here. So you can see where they intersect. And sometimes you may not initially see the intersection depending on your window. So you might have to extend it. Okay? Or you can bring a y2 over. Okay? And you could probably graph this as like your y3. Okay? And then you could just find your zeros. It's really up to you there. Zeros are easy to find because it's right on the x-axis. Intersections can occur anywhere, so it can be a little bit more difficult. But regardless of whatever method you choose, you should get about 12.415. So this does require you to extend your window out to a little bit past 10, okay? Here's part D. Okay, so for t greater than 30, L of t will be the linear approximation at t equals 30. They're saying that that'll be a better model for the amount of grass clippings. Use L of t to predict the time at which there will be 0.5 pounds of grass. Okay, so two parts to this problem. Linear approximation. That's pretty much the equation of a tangent line, okay? So you need two things. You need a point and you need a slope. The point is going to be at t equals 30. And whatever a of 30 is, okay? The slope is going to be the derivative at 30. Okay? So this right here will be a prime of 30. Whatever that is. Okay, I'm going to cheat a little bit. So a prime of 30 comes out to about negative 0.056. And a of 30 is really just 0.783. You pretty much have your point and your slope there. So that's going to be y minus 0.783 equals negative 0.056 times x minus 30. Okay, so in this case, x is really your time. And your y is really your amount of grass clippings, okay? So they're asking you to predict the time where there will be 0.5 pounds of grass. So 0.5 is going to represent your A. Okay. And with just some algebraic manipulation, I can probably simplify the left side here and then divide that negative 0.056 over. And then eventually add that 30 to get t by itself. However you want to do it, you can even graph by intersection if you wanted to, but you should get 35.054 there. Okay?